I'm Anil Kumar. Welcome to my series on integration applications. We'll now find area between the curves. As an example, we have taken find the area of the region enclosed by the parabolas y equals to x square and y equals to 2x minus x square. Let us sketch and understand the scenario. Y equals to x square is a parabola which is opening upwards, vertex at the origin. Right? And 2x minus x square, minus means it is moving down, 1 0 at 0, the other one at 2, right? So it is a parabola which opens downwards. So it will be kind of like this, right? So we have just made a rough sketch here. Area between the curve, we need to figure out what is this area, right? So this is what we need to find. So we have two functions here, and we need to find area in between these. So what we need to figure out is point of intersection. So that is one thing. First thing, point of intersection. So let's find the point of intersection first. Now, point of intersection. The two curves are x square and 2x minus x square. Right, so bringing them together, let's say on the left side, we get x square plus x square minus 2x equals to 0. So we have 2x square minus 2x equals to 0. 2x is common, so we get x minus 1 equals to 0. So that gives you 2 points. One is x equals to 0, the other one is x equals to 1. Now if I put 0 here, then the y value is 0. And if I put 1 here, then y value is 1, right? So 1 square. So we get these 2 points, and as expected, one of them is the origin, and the other one is at 1, 1. So we have this point, which is at 1, 1, and this point is at origin. Now, to find the area, we need to, what we can do is, we can subtract the area of the region between the two curves, right? So that should be in a position that should help us to find the area, right? So what we really do here is that let's consider the two functions. Let's say this one going downwards. Let's call this as y1, right? And the other one is y2. So the curve is between these two curves, correct? So area, we'll consider the rectangles which can be formed within this. So the boundary of this rectangle is between the two curves, correct? So what we have here is, let's find the difference between these two curves, and then we know the interval is from 0 to 1. So we can find the area by finding the expression for the curves, difference between these two curves, right? So let's find what is the difference between the curves y2 and y1. So let's find difference between y2 and y1. So what we get here is okay, so actually we have to take from this one which is going downwards. Let me call this as y2, this is y1. Okay, so 2x minus x square minus x square will give us the region in between the two curves, right? So that region is 2x minus 2x square, right? Now we'll use this particular region to find the area, and therefore the area is now equal to area between the interval when x varies from 0 to 1 and the curve in between will be 2x minus 2x square dx. Right? So that is how we are going to find area between the two curves. Now, where delta x, of course, is each rectangle which we're taking here as the width of this. So this value x varies from 0 to 1. Correct? And on the y side, it is varying from one curve to the other, and therefore we have taken the difference. That is the basic concept. So let's integrate. So we get here the integral of 2x will be 2 times x square over 2 minus, this is 2 times x cube over 3, and the interval for us is, we can write 0 to 1. Correct? So that is how we'll find this. So that gives you x square minus 2 over 3 x cube between 0 to 1. Right? So this is 1 minus 2 over 3. Right? So this is minus, when you put 0, you get 0. Right? So that's what you get. So that gives you 3 minus 2 over 3, which is 1 over 3. So area under this curve is 1 over 3 unit square. Is that clear to you, right? So that is how we find the area between the two curves. So I hope you find it simple and useful. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.